we are beginning with a very, a good opportunity for me. I mean, in fact, I'll share some of my thoughts about this whole area called as space colonization. Okay. Some people are saying that maybe we should not use a word like colonization, which has a negative connotation. Rather, maybe we should call it a space exploration or a space, let's say, human settlement in other celestial bodies. I'll not get into that language related rhetoric. Okay, there is a issue there. How we look at this, there is a issue there. But I'll use space colonization in a very neutral sense. I'm aware of its other dimension, but in this talk, I will use it as a neutral tense. Let me restore my presentation. I'll start. I'm sure most of us who have joined today are, let's say, looking forward enthusiastically to going to space. Suppose if you are given an option, register for traveling to Mars, most likely most of us would jump. I mean, if the offer is really true, that we will jump to take that offer. Space exploration is the one area which has been in the mind of a human being for quite a long time. Sandeep, yeah, okay. So space exploration has been something that has been there in the mind of people for quite a long time. I mean, if you look at all civilization across the world, I said all, whether it is Indian, whether it is Chinese, whether it is European, whether it is what is today the Americas. Okay, there were civilization earlier before Europeans went there. Please remember that. All of them had some dream of traveling to space. Okay, it was all dream. In fact, the possibility of the dream became clear. One second. Okay. Yeah, possibility of the dream came. Let's say people started taking this very seriously and not just purely as science fiction or imagination, but as some potential possibility. With this famous Russian thinker, Tsiolkovsky, who said, Earth is the cradle of humanity, but mankind cannot stay in the cradle forever. Can people mute your mic, please? Yeah, thank you. So, he pointed out that Earth is a cradle of humanity, certainly, not just for humanity, but all life on Earth. But mankind cannot stay in the cradle forever. I mean, it's a very fantastic statement, very, a statement with a lot of depth. Okay. That's how the idea of space travel became important. I mean, he started something called as a rocket club. He enthused quite a lot of people in what is today Russia and then Soviet Union. I mean, he lived in the early parts of Soviet Union, and also a lot of people in Europe, particularly Germany. Okay, so that's how the dream of space travel, the foundations were laid. Uh, yeah, one second. As we all know, the first space craft Sputnik 1 was launched in 1957. One of the early feat. Apparently, when the first spacecraft was launched, the news in the Russian or Soviet newspaper Pravda was a very small one. And then the kind of impact it produced in the rest of the world made the paper to carry a much bigger news next day. That's what historians tell you. So, in a sense, if we talk about humanity, our space age begins with this very small step. Okay, which is a small satellite with which circulated Earth for about 100 minutes. That's it. But still, it showed the potential of space exploration. I mean, again, if we go step by step, some of the initial attempts at entering into space, Gagarin. I'm sure we all know about him. I'm not going to spend a lot of time on this talk on him, but this is a very important step in the space exploration that we are embarking today and tomorrow. In a sense, the first person to go to space. Yeah. In the same way, the Luna 1 was the first spacecraft to reach moon. It impacted. It did not soft land. It crashed on the surface of moon. Okay. People who have joined this show, can you please mute your mic? Yeah. So this is the first series of Soviet automatic interplanetary stations. Although Soviet Union also considered sending humans to moon, right from the beginning, one of their attitude was send automatic missions. So this is one of the automatic mission that that was sent towards the moon, which is important in history milestone. Similarly, the Luna 2, which circled the moon and took the photograph of moon, the other side of the moon, first time. Although also it impacted on the moon surface in 1959. Okay, and in 1966, the Luna 9 became the first vehicle to safe land on moon surface. Later that year, Luna 10 launched became the first craft to orbit the moon successfully. It's a really very interesting that nowadays when we explore, for example, India attempted to reach moon or China attempts to reach moon, first we are trying to put an orbiter, then maybe crash land, then soft land, then rover, etc., etc. Okay, but it was kind of the other way around when initial efforts were taken on. Okay, so these are all important milestone in space exploration. And of course, a very key milestone like Yuri Gagarin is the small step for a man and a giant leap for mankind. The Neil Armstrong putting his feet on the surface of moon. Okay, historic pictures. If nobody disturbs it, it is supposed to last for millions of years. Okay, unless otherwise randomly some space rock comes and falls on this footprint. This footprint is expected to survive for millions of years. Okay, as there is no wind or water on the moon surface, the features remain for quite a long time. Okay, this is a historic photograph, video grab from this Apollo 11 mission. Yeah, and we had the first space station, Mir. It operated between 1986 to 2001, and this was assembled in orbit, module by module. Okay, and it hosted more than 100 space travelers from dozens of countries, including India, France, Germany, Japan, even Afghanistan. This is an important point, about which I'm going to tell later why this is important. Okay, I'm going to talk about it later. So this was first space station, of course, now not in operation. I mean, it was deorbited. Surender, are you there?
Yes, sir. Yes, sir.
Can you ask others to mute?
Sure, sir. Sure. Participants, others, kindly mute your mic. Unless otherwise, if you have any questions, kindly post your questions in the chat box. Don't unmute.
Yes, yeah, thank you.
Sorry,
thank
sir.
You. Sorry, it's okay. It's okay. So this is an important step in space exploration. Yeah, and I'll tell you why although this space station belonged to Soviet Union, why people from other countries were taken. I mean, of course, there are many reasons why, but one of the important reasons about which we'll talk in the end of my talk. Okay. If you then go forward, the exploration of space, one of the other major milestone is Voyager 1 and Voyager 2. Okay. So Voyager 1 had entered the what you can call as interstellar space in 2012, a very important milestone, which means that a human-made object has left solar system. Okay, in the history of space travel, this is a important event, and Voyager 2 crossed, and similarly again in 2012, the Voyager 2 had also crossed into interstellar space, right? So now we have two human-made objects which are in the interstellar space, although they are not functional so much. Once in a while, you can, I mean, people are trying to revive it using its meager power to present us with some information. Okay, so still it is giving scientific information about interstellar space. Some crucial information we have even received in the recent past. Okay, we talked about something that was happening in the space. Meanwhile, right from the beginning, there were also dream of sending human to space to interstellar region, which essentially means we need to find ways of ensuring humans surviving in harsh conditions of space. Let's take, for example, there is no way once you send a spacecraft into space, you can send supplies from Earth regularly, which essentially means that some or other your environment within the space should be such that you are recycling everything. So it should be self-sustaining. Okay, so that's a very key point. To test the self-sustainability and also problems associated with long isolated travel in Soviet Union, they created a facility around 1970s. It was functional up to mid 80s. Okay, called BIOS 3. It's called a Mars stimulator. Of course, one of the first stepping stone, if you're talking about the long-term human travel, people are thinking of Mars because it's going to take about 6 months minimum to reach there. So it's more than a year if human have to go back, go and come back. Yeah. So this facility, which was created in Soviet Union, you can see some of the pictures, is called isolation chamber, where nothing much is given as input except what was given originally. Okay, and they tested whether you can actually ensure recycling of let's say oxygen, recycling of water. Okay, two important components that if people have to go. So three people lived there, and then in the experiment they were able to show that almost 95% of water they were able to recycle. Okay, and they were also able to produce edible plants. I mean, if any of you have seen this film Martian, okay, some of these ideas actually comes from this kind of experiments actually, which was done. Now it is not functional. It has lived its utility, but there were other experiments which were also conducted called uh, in US, in Arizona. Yeah, so where they are trying to grow plants in Martian-like conditions. Okay, so similarly, a experiment is going on in the International Space Station to grow plants. You can see those pictures, which are from International Space Station's uh, experiment to grow plants. So while so many other things are happening in the International Space Station, a small component is also spent about human survival, long-term human survival in space. Okay, uh, this is Comet Bennu, where not Comet Bennu, I'm sorry, the asteroid Bennu, where recently the NASA spacecraft landed. It mined, it took some material. This is again important landmark in space travel in terms of space exploration and expedition, basically because now you can start thinking about space mining, a new concept which has emerged in the recent past. Again, I'll talk about it a bit later. So one of the idea is in on Earth, mining is becoming very difficult for multiple reasons. One, we don't have enough resources. Number one, surface level. Then you have to go very deep, which essentially means a huge environmental challenge. Uh, so, is there a way, for example, you can bring materials, particularly certain metals, from space? Okay, one is not talking about bulk materials like, say, for example, iron. It may be very difficult because you may need uh, huge quantities. But there are materials like rare earth elements, okay, which are needed for electronics, nanotechnology, okay, upcoming technologies, where the quantity that will be required all over the world is not very huge. So it is feasible. Of course, you need to improve our space travel capacities much more, but it is feasible in near future terms. Like, for example, if you are looking at next 20 years or so, it is a feasible proposition. So, one of the areas in which people are exploring today is that can we mine celestial bodies, be it moon, be it asteroids, be it Mars, and bring back high value products which are required in small quantities. Okay, uh, this is one exploration, and second is can you use some of the celestial bodies for various kind of scientific research? Like, say, for example, can you create a radio telescope using the lunar crater? Okay, so on the moon you don't have a heavy wind, there is no cyclone. Okay, so you can happily construct a radio telescope on the surface of the moon, and with no atmosphere you will get a better results. Okay, so these are all some of the ideas which are emerging in the international space community of utilizing space for commercial and research purposes. Okay, so this is another space exploration area that is going on. Moon particularly, people are looking at mining helium-3. Helium-3 is an isotope of helium. Uh, one of the biggest experiment right now going on Earth is called ITER. Okay, ITER is a international research station established in France. India is a partner along with European countries plus USA, Russia, China. Okay, major about 20 countries are partner in that program, where by nuclear fusion, not fission, the current nuclear facilities, whether it is in Kalpakkam, whether it is in Trombay, they all use fission. So you use radioactive materials like uranium or plutonium. Okay, but the ITER is trying to mimic the processes happening inside a star. That is combine atoms, that is fuse atoms to produce energy. Okay, so nuclear fusion. So for nuclear fusion, helium-3 is one of the best fuel. And helium-3 is available on the surface of moon in abundant quantities. Extracting from surface of the moon would be much easier than extracting from Earth. Earth also it's available, for example, in seawater. But then you have to process huge quantity of seawater to extract that helium-3, which may have a lot of environmental consequences. So it's not something that is going to be that easy. And you need only a small amount of helium-3 because it's a fusion process. You don't need in huge quantities. So one of the actual plan that people are working on is mining helium-3 on the surface of moon. But then along with the helium-3, if you mine moon, then you will also get materials like titanium, which is again not easy to get on the surface of Earth. Okay, so it will be double whammy. I mean, you can mine both of them, and maybe possibly you will export helium-3 to Earth, but whereas use the titanium to construct further facilities on the surface of moon. That's maybe not, you may not bring the titanium-3 to titanium to Earth. Okay, maybe it will be too costly in the initial phase, so maybe, but you can use it to build construction facilities, infrastructure on the surface of the moon. Yeah. So very seriously, people are looking at establishing a production facility on the surface of moon. I'm sure many of you might have heard about ISRO, not just ISRO, actually, ISRO, and there is a CSIR institute in Calcutta called Central Glass and Ceramic Ware Institute. Okay, they are looking at can you use the soil of moon to prepare some kind of a ceramic. Okay, so if you can prepare on the surface of moon, then you can use that as a construction material, and then construct, for example, road or habitation. Okay, so this is one area. Similarly, a group in Indian Institute of Science, Bangalore, as again in collaboration with ISRO, has worked on moon regolith to find out if you can create bricks using moon soil. Okay, it's a very fine powder. Moon soil is a very fine powder. So can you use it to produce bricks? Very interestingly, for example, the IISc, Indian Institute of Science attempt is using a particular kind of bacteria. Okay, so that bacteria and a particular resin that comes from gore, one plant, if you use them together, then it can create into a hardened brick material. That's what the research is looking at. So it is not the traditional ways of making construction material. So you are now looking at some kind of a biological process. Okay, because these are all possible in moon. You can take small quantities of bacteria and then use it to culture more bacteria, etc., etc. Right? So people are looking at that kind of option. So this is a interesting arena that is going on. Now let me go to the next one. Sorry, next one. Here you see that there is something called as a lunar gold rush. If you carefully look at the space exploration timeline, 1976 was the last mission, Luna 26, that went to moon and came back to Earth. After that, it took almost 14 years before we started sending mission to moon. Because with the earlier technology, you had almost done what you can do with moon. But with the new technologies like 3D printing, new ideas are emerging. Okay, so some people are calling this as lunar gold rush. It is very similar to, for example, in US in the 19th century, there was something called as a California gold rush. Okay, a lot of people moved to California because, I mean, there was an indication that there is huge amount of gold over there, and then that's how the whole California became inhabited with Europeans. Okay, in the same way, today people are talking about what is called as a lunar gold rush. Okay, so basically, like I was pointing out, using moon as a surface to extract important materials, like as I was talking about helium-3 for nuclear fusion. Okay, you can you can harvest, for example, scandium and yttrium, which are important rare earth material for electronics, which are found in moon in good quantities, substantial quantities, mineable quantities. Okay, yeah. So people are saying that this could work in 3 stages. The phase 1 is going to moon. That's what now countries are doing, trying to soft land, trying to do rover, trying to do mining. For example, the Indian Chandrayaan 2, if it had landed, then it would have also done some amount of uh, what you can call as micro mining. I mean, not mining to extract material, but at least drill and find out what is there inside. Okay. Phase 2 is unclear. What should be the next step is not clear. But of course, our goal, phase 3, seems to be clear, which is like extract minerals. Okay. The SpaceX, the private space company, which is in the news for in the recent past, is essentially eyeing for it. Okay, that kind of a commercial potential, in addition to, of course, tourists. These are the two areas in which SpaceX is looking at its monetization. Okay, why, for example, today it has become a possibility, and maybe after 76 we were quiet for quite some time. One is the emergence of a new technology called 3D printers. It's also called as additive manufacturing technology. Additive. Okay. What is additive? That is, if I want to manufacture a product, I add layer by layer. Okay. So that's why it's called as printer. Okay. This machine can take the raw material and then add layer by layer the way we want, and then produce a tool or product, whatever that you want. Okay. So with this 3D printing technology, now what you need to send to moon is only a 3D printer, different kinds of 3D printers. Then you can extract the raw material from the moon and then construct your own products. In fact, you can even construct a 3D printer. Okay, maybe a few components you may have to take from here, IC chips or something like that, but rest can be constructed on the surface of moon itself. Thereby, the possibility of producing equipments on the surface of moon has become reality. Earlier, there was a dream, even when the first spacecraft landed on moon, about moon habitation. But then every single brick you need to transport from Earth to moon, which would have been very difficult, very costly. Okay, not feasible. You might have to send rockets every day. Okay, one by one, like a train. That's not that simple, right? But then with the 3D printing technology, now you need to send only crucial component. The rest can be done from there itself. Okay, so with this idea, people are talking about robot miners. That is, you are not sending human beings to actually mine, not people, but robots. Now robots have our robotic technology has improved, so that possibility comes in. Robots can be built by 3D printers, for example. Okay, except maybe a crucial component, as I said, maybe electronics or something like that is the only thing that you need to take, which you can take, which is not in bulk quantities. The rest of the thing can be made by the 3D printer. So you can establish a complete lunar base with minimal input from Earth. Okay, that's a possibility that is seemingly available with the emerging technology. Okay, with the emerging technology of 3D printers and robotics, machine learning, these are becoming potentially possible. So what will be its consequences? People are now worried. They are saying that if you mine, would you not take away a lot of material that will affect the tides on Earth? Okay, not really. We are that the target is even if you remove about 1 metric ton per every day. Okay, it will take 220 billion years to deplete 1% of the moon's mass to have any even noticeable consequences on tides. So in that sense, we are not going to have a big trouble from mining moon. I mean, these are all some simple questions that people have. Naturally, we need to. But the biggest concerns are something else. Okay. What will be its impact on future generation? What the cultural connotation of moon? Okay. Stakeholders, which again I'll talk a bit more in the end. Okay. Uh, and visual impact. Suppose if we create more craters, will you have the beautiful moon as we have today? These are all some questions that we need to ask, which are basically environmental and ethical questions. Uh, okay. This again I'll come to a bit later. Then the other object which is high on the priority of space community is asteroids. Not big ones, smaller ones. Okay. Asteroids also contain a lot of interesting chemicals, including iron, substantial quantities of iron. Okay. Cobalt, nickel. Okay. It also has various rare earth materials like iridium. Okay. They are all needed for various kinds of important products. For example, LCDs, cancer treatment, catalytic converters. Some of these materials are used. Today, we are mining them at a huge environmental cost. So there are people who say, can we just drag a small asteroid, bring it to Earth? Okay, when I say drag, you don't really mean that you drag it and then bring it on Earth. Mine it, bring the material on Earth. Okay, so a robotic mission which can go to an asteroid, mine, take material that you want, like as I said, with the 3D printers and things like that. I mean, robotics, it's again seemingly technological possibilities. Okay, with that, you can bring in materials which are required on Earth with least environmental cost for Earth. Suppose once you mine, that asteroid will be gone. Okay, if you mine an asteroid which is a few tons in mass, it's not going to substantially impact the orbits of planets, or it's not going to make that kind of effect. So again, you don't have that kind of fear from removing an asteroid from its orbit. Okay, that's not a major problem. Yeah. This dream of drilling and taking material from asteroids have been something that has been there for quite long time. This dream today, but may not happen with humans. Today, it may happen with robotic gadgets, okay, bots, okay, which are called as mini bee. There is a new technology that people are working on called as bee technology as far as the space is concerned. So honeybees, queen bees, etc., etc. Okay. So this honeybees will go collect material. Queen bees will keep it and then bring it back to Earth. You know, this kind of one constellation that people are dreaming about. Again, these are all only in the drawing board. These are not realities. It will take quite a long time before we do it, but people have started dreaming about it because the technology is possible. Okay, not merely science fiction, but these technologies, many of things are available today. Okay. Another important step in space exploration is what has been recently launched towards Mars, called MOXIE. This MOXIE is, you can euphemistically call as artificial leaf or artificial tree. So like a tree produces oxygen from carbon dioxide, this gadget can convert the carbon dioxide of Martian atmosphere into oxygen. Okay, so right now it is a experimental setup which has been sent there to see how it works, what kind of problems you are having, how long it will work, what kind of issues are there, etc. But this is the first step towards if we are sending humans to Mars, then perhaps instruments like this will be sent much ahead, so that oxygen is stored and be ready before the humans land there. So oxygen is needed for both human respiration, and also if you want to use some fuel, oxygen would be required as an oxidizer, right? So for that, you create oxygen and keep the reserve much before humans go. So your first step has taken place. Somewhere in February next year, this will land. This American mission will land on Mars, and then it will work for about 8 to 10 months. And by then, that is by end of next year, we will know whether this instrument is working, what kind of challenges are coming from this instrument. Okay. Uh, with this, there are number of technologies which are aimed at the Martian visit is being planned. Unlike Moon it takes about 2 to 3 days to go and come back, but Mars will take about 6 months one-way journey. So, which means that you cannot land on Mars, stay there for a day, and then come back. It will be meaningless. It will be senseless. Okay, and I don't think anybody would spend huge amount of money for that kind of a one-day demonstration. So if you go there, you will stay for some time. I mean, at least a month or so. So it means that you need the complete survival kit for Mars. Okay, so number of technologies which are required for Martian life are being experimented. They are being built. They are being tested. Doesn't mean that you can just export them and immediately land on Mars, but one is looking at what kind of problems will come, what kind of issues will come. So, like this vehicle, yeah, Martian vehicle, people are exploring things right now, constructing. Okay, there are a number of things which are being constructed. Similarly, if you are going to Mars, we will be at one point of time. I'm absolutely sure about it. You will need to grow plants to get your oxygen and also produce your own food. So similar experiment, as I said, are being undertaken in various places. Now let me come to one important aspect of this space exploration or colonization, whatever way we want to call it. The major challenge today is not technology. It is a challenge. Technologies are not available. It's going to take a lot of time, effort, ingenuity to create technology, but the potential exists. Okay, 3D printers, as I said, additive manufacturing, uh, robotics, the machine learning, all these things put together, the potential is already there. There are but two other important challenges. Okay, so that's what I'm going to talk in the next part. Two other very important challenges which as humanity we need to face. Okay, what is the challenge? First, let me tell you that there are already 5 international treaties with regard to space exploration. Okay, the first one was signed in 1967. Treaty on Principles Governing the Activities of States in Exploration and Use of Outer Space, including Moon and other celestial bodies. So now I'm going to tell you the context of this first treaty, which is very important because that is what is going to that's what has impacted on all other stuff. Remember, I told you about Luna 2, which landed on Moon. Okay, what Luna 2 had was a very interesting contraption. The contraption was like a spring. So once the Luna 2 landed on Moon, like a flower opening, the lander opened, and there were a lot of small springs and small flags of Soviet Union. This small flags of Soviet Union were thrown on the surface of Moon in large area. In international law, there is a law called as finders keepers. What does that finders keepers mean? You are traveling in let us say ocean. You find an island. The island is inhabited. It is not part of any country as of now. You are the first one to go there. Then that island belongs to you. Understand? Okay. So if you are the first person to step on that island, then that island belongs to you. Now, Soviet Union was the first country to land on moon, and it has thrown its flag all around. Can Soviet Union claim that moon belongs to Soviet Union? Or at least one part of the moon belongs to Soviet Union? This was the legal question that emerged during that time. Okay, so America was scared. If you apply that finders keepers law, then if Soviet Union made a claim that moon belongs to me because I am the first person to go there, then America cannot make a challenge. That's when America said that we should have an international treaty, we should start discussing, and then called all the countries. And then this international treaty was drafted, 1967. I'll tell you what the treaty says, which has an important ramification for today. And subsequently, there were 4 more treaties which were made. The other one is about rescuing astronauts, which is like cooperation in the space. Suppose if one country is in trouble, the other country can go and help. That kind of stuff, which is humanitarian, that's fine. Then intentional liability for damage caused. That is by leaving something that you are causing damage to somebody else's space object. Like say, for example, I secretly send one spacecraft or a satellite, it's going around, and then another country is sending a satellite, and my satellite goes and hits that satellite. Then because I have not declared my satellite, I've intentionally caused a damage, right? So that kind of things are controlled by this treaty, where we are not expected to do that. Okay. Then similarly, with the space junk increasing and position in space were not available. Okay. This the 4th law, international law, was established in 1975. Convention on registration of objects. You don't need permission. If India has to launch a satellite, you don't need permission, but you register so that the other countries know that you are sending a satellite. That satellite is going to be positioned in so and so place. It's a very important point because you should understand this part. Let's talk about, for example, geostationary orbit. This is not a major problem in other orbits, but particularly geostationary orbit, it's an important problem. So geostationary orbit is by and large one circle. One circle exactly above Earth's equator, again by and large. Okay, so all these things you have to keep with minor variation. In a very simplistic manner, I'm explaining. So geocentric essentially is a circle in the space about 45,000 kilometers above, exactly above the Earth's equator. Okay, so then there are only so much of space around that geocentric orbit. Let's assume above India, okay, above India in the space, in the position of geocentric orbit, some other country, let's say USA, goes and parks lots of satellites. What do I do? Even if India sends a satellite to geostationary orbit, it cannot park its satellite above India, right? You have to park it above, let's say, somewhere else, but then it's of no use to you. Okay, so the first person who goes and occupies will have a advantage. Not only advantage, that person will become monopoly. Okay, so that is why this registration came in, so that some kind of international regulation that people are not trying to foil other countries' chances. Okay, so that's how this this law 1975 came in. Okay, next is also a very important law, 1979, Agreement on Governing Activities of States on Moon and Other Celestial Bodies. But the last one, unfortunately, is I mean, popularly this is called as a Moon Treaty. Okay, this is called as a Moon Treaty, and actually, as you can see, it was in 1979. The last mission to Moon took place in 1976. So, by and large, by the time this treaty was agreed, finally, uh, most countries has lost their interest on Moon. Okay, so and I'll tell you more about this treaty little bit later, which is an important one. So the first one and the last one are important, about which we are going to discuss a bit more. Okay, so the Moon Treaty, the last one that I talked about, the Article 11 says that the Moon and its natural resources are common heritage of mankind and is not subject to national appropriation by any claim of sovereign by means of use of occupation or by any other means. What does it mean? Like the application of enterprise system to oceanic resources, the natural resources of Moon is, according to Moon Treaty, entitled to equitable sharing by all state parties in benefits derived from these resources. What does that mean? It does not matter which country dug up the resources, that country alone cannot have complete and exclusive ownership and control over such resources. This is a key issue. Moon Treaty. The fifth one, 1979. Okay. This means that if I go to Moon, I collect resources, I cannot claim that that is mine. It's a common heritage of human. I have to share with others. Okay. According to this law, according to this treaty. What does it mean? Private ownership on Moon or other celestial bodies, according to Moon Treaty. Actually, it is not only Moon Treaty, it's about all celestial objects, but popularly it's called as Moon Treaty. It has two implications. Can a private enterprise own resources they mine? That is, if say SpaceX goes, mine something from Moon, can SpaceX say that it's mine according to Moon Treaty? No, there is a problem. Property right on Mars, not just Mars, on any place. For example, even an asteroid. Okay, can a private company say that I have my honeybees and queen bees have captured this asteroid, so all the resources in that asteroid is mine? Can they say that? Can they say that I own this asteroid? These are all important questions which come from Moon Treaty. Like as I said, the Moon Treaty was finally agreed upon in 1979. Even after agreement, the countries have come and sign. Okay, so it came to force in 1984. Most of the spacefaring nations, United States, Russia, China, Japan, several European countries have not ratified this Moon Treaty. Okay, they have not ratified this Moon Treaty. It means, although it is an international law, it is not accepted by majority of, important nations. Because of that, the Moon Treaty is going to be renegotiated soon. People have started already discussing about that. Okay, they are going to discuss. That is one of the reason why many countries rush to Moon, because if you have not gone to Moon at all, and the new Moon Treaty says that only people who have gone to Moon will have the right to discuss about Moon. Like say, for example, there are nuclear power, right? Nuclear weapons. There are only 5 nuclear weapon states. Why? Because the date on which that treaty was done, there were only 5. They said that we won't accept any new people. Okay, so same way, maybe the big countries will say that today whoever has reached Moon will have. Then that's why many countries like Japan, etc., rushed to send their spacecraft to Moon. Right now, UAE has sent its spacecraft to Mars, which also means that UAE will be now able to claim a role as a spacefaring nation. if they make some classification like that. Okay, so these are all important questions for future. Hmm. Yeah, so this is where we are coming to the end of my talk. Then we'll take questions from you. So there are this important challenge. Two issues I said. One is, can a private company or a country own celestial bodies? Second, if we get something from these celestial bodies, can it be a private property or belong to only one country or to the whole world? These are two important questions. Okay. Uh, you may think it as a very simple issue. It's not a very simple issue. Today, almost any electronics that we use, my laptop or whatever device that you are using, contains a small amount of rare earth minerals which are mined in Africa, okay, by poor African people. And then we are creating new resource using these gadgets, like me, okay, using this laptop. Many others are using laptop. That's how, or many other electronic technology. Can we really say that without that poor African worker, we will be able to actually perform what we are performing now? Not really, right? It's unseen, but the poor African worker is part of what you and I are doing today. So if, in a way, any technology that you are going to develop, rockets, anything that you are going to develop, there is going to be an unseen hand of this poor African. So any benefit that you get out of the space technology, should not some portion of it rightfully belongs to that African worker or that country or the people in that country? That's an important question to ask. Okay. Second, in Earth, we have two kinds of international treaty, or rather two models of international treaty. I'll explain 1 minute. There is a law of ocean, and then there is also Antarctica Treaty. Now let's look at the law of ocean. Who owns the ocean? Nobody. I'm not talking about the economic zone or your border along the sea coast. No, I'm not talking about that. High sea. Okay. If you go beyond 12 kilometers from your seashore, okay, what is called as international waters. International waters. Who owns it? Nobody owns it, and nobody can own. Even if you establish some facility, you cannot claim ownership. The ship, for example, if flies India flag, then the ship is considered as India. So anything that is happening inside the ship is considered as, is covered by Indian law. Okay, but rest of the water is international. Anybody can come, anybody can go. Right? This is one law. So nobody owns. It's a common property, common heritage. Look at Antarctica. The Antarctica, if you go and look at a political map of Antarctica, you will see it like a cake slice. Okay, cake slice. So the part of Antarctica, I mean, if you look at the world map, above and below in the normal sense, like north is above, south is below. The part of Antarctica just below Australia belongs to Australia. Just below New Zealand belongs to New Zealand. Just below some South American country belongs to that South American country. Exceptions are there. US, which is in the northern hemisphere, owns a part of Antarctica. Okay. But then many other countries like India said that, why not we? Why only you? No, we were the first to go there. We have sliced it, so we own it. So there is the Antarctica Treaty, which is unequal, which are owned by different countries. Okay, although one of the clause permits other countries to go to Antarctica for scientific work. Okay, there is no ban on that. But in terms of resources, the Antarctica Treaty is not like the law of ocean, where nobody owns, it's a common property. No, that's a property. Okay, there are properties regime in Antarctica. So now the question is the celestial bodies. How do we look at it? That's an important challenge. So these are two challenges which are as a human being, as a person of this Earth, planet Earth, we need to explore. I mean, these are two important challenges for space exploration, future space exploration, colonization that is there before us. Okay. With this, I'll stop my talk. I'll take questions. Thank you.
Thank you, sir. Thank you very much. Now this is time for questions. Participants, you can ask questions if you have any. Sir, there are few questions in the YouTube live.
Yeah. Please let me, so then I can. Yeah.
Yeah. I will post in the chat box. Perfect.
Yeah, please.
We're now unmuted.
Hello, sir.
Yeah, Manoj Kumar, please.
Good morning, sir. How are you, sir?
Yeah, good.
After this corona?
Yeah.
Sir, before that, I want to ask one question to you, sir.
Mhm.
So in that, in Martian perspective, there is 95% of carbon dioxide percentage there. That's quite interesting one, sir. But before that, I read a past one paragraphs about using electrochemical cells by it can able to convert carbon dioxide into electricity. Means is there possible to applying like this, sir?
Can you be a bit louder? I can't hear you.
So is there possible to applying electrochemical cells which is using for converting carbon dioxide into electricity, sir?
Carbon dioxide into electricity. I have not heard of it. Sorry. There are two kinds of work which is going on, in my knowledge. One is converting carbon dioxide into oxygen. That is one. The second is can you convert carbon dioxide into hydrocarbon, like methane or other hydrocarbons, then which can become a fuel. These are, the second one is happening through nanotechnology, whereby you are fusing carbon dioxide to come together very close so that they can become methane. No, that kind of effort is on. These are the two things that I've heard of. I have not heard of directly producing electricity from electrochemical means. Sorry, I'm not aware of that.
We're now unmuted.
Okay, sir. That's another one question, sir. So in 2008, Chandrayaan was found about the water content on moon.
Yeah.
How much amount of water is content, sir? Like the water is content about like earth, level of Earth.
Okay. The average water on moon is 1/100th of the water that you can find in Sahara Desert. I mean, if I have disappointed you, sorry. But that is not the important point. The important point is that in some of the craters in the poles, there are places which are under permanent shadow. So there, the water can be in good quantities together. I mean, it at one place. And in the rest of the moon, water is found inside the surface, subsurface. Okay. These are the two kinds of discoveries that Chandrayaan-1 actually found. And interestingly, the first evidence of water on moon was by Indian equipment in the Moon Impact Probe, which, to my opinion, many people are not properly acknowledging. Maybe in the chat section, I'll share a link where I have written about it. Okay. Yeah. Where I'll I've written about it. Okay.
Thank you, sir.
Or maybe you can give that link in the chat note. We will download it and share it in a mail.
Yeah. Whichever way. I'll share it in the chat box right now.
Sure. Yeah.
Samir has also put a very interesting link In addition to his link, I will also suggest people to read a trilogy called Martian Trilogy. I was trying to locate it today morning, but I couldn't easily locate. Okay, it's called Martian Trilogy. It's the book titles are like Red Mars, Blue Mars, Green Mars kind of stuff. Okay, it's a science fiction, but in my opinion, very good science fiction where they have explored various issues in colonizing or exploring or human settlements in other planets, particularly Mars. This one talks about Mars. Okay, so if people are interested, I think they should also read that science fiction. Yeah, maybe I'll also share that link here. But yeah.
You are now unmuted.
So there are few questions.
Yeah, please.
I have posted in the public chat.
You are now unmuted.
Vaibhavi has asked, what are the materials in Moon? Why we need to concentrate on Moon?
Okay. Right now, the most interesting material that people talk about on surface of the Moon is helium-3. Okay, like I was pointing out, the helium-3 is a very important component for nuclear fusion that people are working on. For example, the ITER or other nuclear fusion reactors that we are building right now, they can work with helium-3 efficiently. And using helium-3, if we work producing electricity, then quite a lot of environmental challenges will be we'll be able to face, we'll be able to solve a lot of environmental challenges of using coal or other kinds of, including nuclear power. Doubts about radioactivity, etc. Okay, nuclear fusion is safe in the sense that there is no radioactivity coming out of nuclear fusion power plants. Okay, in India there is an institution in Ahmedabad, uh, IPR, Institute of Plasma Research. They are also partnered in the ITER project, where internationally, in a collaborative way, this demonstration nuclear fusion plant is being established. They are looking at something like 2030, like another 10 years for demonstrating this whole technology. So, if the technology is working very well, then you will need isotopes, right kind of isotope, and helium-3 is a good isotope. As I told you, that harvesting that in Earth is going to be slightly difficult. So harvesting from Moon might be much easier. Yeah. Okay.
Hello, sir.
One question by Devan Rati, so which is already there in the chat box. First, let me take that and then go to the other one. Can I do that? So yeah.
Yes, sir.
Devan Rati. What are the major key factors that we have to answer for the possibility of human colonization in outer space? One is technological. As I said, a lot of technologies are developing and the potential exists. But in my opinion, generally the key challenge is not technology. Technology seems to be the major challenge. It is a challenge, but it's not the major challenge. Major challenges other aspects, science society aspects. Is the human colonization for the benefit of one small section of human being or for the whole humanity? This is an important question to ask. Okay. If it is for whole humanity, then how are we going to ensure that it is going to benefit all humanity and not only one small section of human beings? That's the important part. Second, what the resources that we garner from space, is it going to be a private property or for public good? Okay, these are all important questions that we need to answer, because that's going to decide why this human colonization, or whatever name that you want to call, of outer space. Okay, is it going to be another means of generating iniquity on Earth, or is it going to be another means of ensuring that the iniquities are removed? These are the questions that we need to ask. Okay, between nations, between individuals. Okay, if you have to colonize space, how will we avoid space radiation and cosmic rays? It's also a important technical challenge. So, like even traveling to Mars is not going to be that simple. You have to have some kind of a radiation shields. People are working on it. Various kinds of technologies. People are working on it. Yeah. So even if you are going to be in Moon, etc., you will need that kind of a shield. Yeah. Next one is, can you elaborate Treaty of 1967? Yes. Shall I share my presentation and then go back to that slide? Yeah. So this is the Treaty of 1967, which is called United Nations Outer Space Treaty. No nation can claim ownership on Moon or any celestial body. That is, you cannot put a fence and say that this area belongs to me. Okay, except your own craft. I mean, it is very similar to, for example, the law on ICs. You cannot own the ocean. Okay, I'm talking about beyond the border. There is a sea border. I'm talking about beyond the sea border. Okay, beyond the sea border, you cannot own the ocean. But if you have your ship, that ship, if it flies Indian flag, then that ship is a Indian territory. Okay, anything happening on the Indian ship is covered by Indian law. Similarly, if you land a spacecraft on Moon, that spacecraft will be governed by the laws of the country which launched it, or the flag under which the spacecraft is flying. Okay, so that is why when, for example, when the Soyuz and one of the Russian station Salyut joined in space. Okay, the American and Russians combined to produce one joint thing. They entered into a negotiation saying that how the laws will be governed. In this part, the Russian law; in that part, American law. But if the American comes to Russian part, what will happen? If when the Russian go to American part, what will happen? Similarly, there is a law agreement between countries which are going to International Space Station. Okay. Yeah, there is one point that I told that I'll talk about, which I forgot. I mean, I missed it. I'll come back to it, which is why this Mir space station, which was launched by Soviet Union and sustained by Soviet Union, hosted 100 space travelers, and many of them from different countries around the world. India, France, Germany, Japan, Afghanistan. That is basically coming from this outer space treaty signature. So the Soviet Union said that let us honor this outer space treaty, and because the outer space is a common human heritage, even if the space station belongs to Russia, the vehicles belongs to Russia or Soviet Union, we should somehow or other take other country people also to the space so that it will become a common heritage. That was the understanding. But that is not the understanding in International Space Station. Please remember, no Indian, I mean Indian citizen, Indian born American might have gone, but no Indian citizen as is entertained in International Space Station. Okay, it is it's a treaty between some countries. So only space travelers from those countries are entertained within the International Space Station, right? So this is something that we need to keep in mind. How things are changing, and is it changing for good or bad? I think we need to all think about it. Okay. What is the scope of astrobiology in coming recent years? Is there any institution in India which one can study astrobiology? I think perhaps later mm, Samir is going to give a talk. I would pass on this question to him. Samir, if you're over there, please put it in chat, and perhaps maybe you should take it up when you give a talk. you would be better person to talking from Ayuka. Okay, I'm not very clear about it. So, what is the human moon treaty? The moon treaty is a treaty that I told was signed, the last of the 5 international treaties. But the moon treaty is not ratified by many of the countries. So, which is although according to United Nations, it's in force. None of the major spacefaring nations are signatory to it. So, the moon treaty bans ownership, and it talks about a common human heritage of moon and celestial bodies. So it is not something which permits, for example, private ownership on celestial bodies. Like you can own a mine in Earth. It doesn't permit ownership of material on other celestial bodies. Okay, that's one of the important aspect of that moon treaty. Soon the moon treaty will be coming up for renegotiation. Many of the countries will start talking about it. I mean, of course, we don't know how it will go. Yeah. Okay. In Antarctica, if Antarctica is owned by a particular country, then why not America is accepting itself responsibility for the pollution? Antarctica is owned by different countries. Different slices of Antarctica is owned by different countries. Okay. Within that portion, or rather, there is a claim. The Antarctica Treaty makes a claim. Not all countries are accepting that Antarctica Treaty. For example, India does not believe that Antarctica should be owned. Okay, there are differences. Still, things are not settled. But I was just pointing out that how a issue on Earth are being dealt in 2 different ways. For example, the ocean is a common property of the world. Nobody owns it. Okay, but whereas Antarctica, there is a strong push for ownership by nation. You are not treating Antarctica like the ocean. Okay, basically because people know that there are huge amount of resources under Antarctica, and there is a possibility that one time you may take it, so you want to claim ownership. Okay, so that's the thing about Antarctica. So the question that I was talking about is not about Antarctica or ocean. That's not the important point. How do we deal with celestial objects, moon, other celestial objects, Mars, asteroids? Okay, how do we deal with it? That's the key question that one was talking about. And how should space technology behave? Should it behave in a fashion which will provide equity, or which will provide impetus for more inequity to grow? Okay, and if you want to understand this bit more, one of the easiest way, in my opinion, is to read this Mars trilogy. It's very excellent. They have dealt with many of these kind of questions and its implication in a very interesting way. Okay, and makes you think in that sense. Thank you. Anything else?
Thank you, sir. Thank you very much. I think there are no questions in the YouTube as well as platform. Participants, if you have any questions, you can ask. Otherwise, we will close.
Hello, sir.
Yeah.
Sir, my question is that on which basis were the language written on the Voyager 1 chosen?
I don't know the answer for it. Sorry. Okay. I don't know what is the basis for what are the languages that they chose to put on Voyager 1. I have not read it, so I can't say that.
Okay, fine. Thank you.
Thank you.
We're now unmuted.
Hello, sir.
Yeah.
Yeah, sir, one more question, sir. One more question, sir. So in future, is there possible to India will join with the International Space ISS, International Space Station?
As of now, neither ISRO nor the government or any other people have talked about India joining International Space Station. ISRO is talking about launching its own space station in near future. China, for example, has also announced that it will launch its own. I mean, it's already has a space station, which it says that will build more. Okay, I mean, will expand. That's what is the current scenario.
You are now
Okay,
unmuted.
okay, sir. So I was very much interested in astrophysics, sir. Is there any bright future for the scope, sir?
I think about the courses, maybe you should discuss with Samir, who is going to talk today evening. Yeah.
Okay, sir.
I mean, he is from Indian University Center for Astronomy and Astrophysics. So about institution, what are the core possibilities, what are the availabilities, maybe you'll be able to give you a better idea, okay, in India.
You are now unmuted.
Thank you, sir. Have a nice day.
Thank you, sir. Thank you very much. I think it was a wonderful session. So many questions, many discussions. Yeah.
Thank you everyone for this very wonderful opportunity. I am also thankful to all the participants and also to the organizer for this great opportunity today morning. I mean, it made my day.
Yeah, thank you, sir. Thank you very much. So CSTERC is going to organize another set of three programs after that. Sami sir is going to deliver another session, and Subramani sir is waiting, and Ardhani is going to deliver about satellite communication. So it is kind of popularizing science as well as actually Chigru is a worker-owned cooperative structure, and we are mainly concentrating on technology and science part to intervene in that part. It is kind of cooperative structure we have established now.
Very nice,
Yeah.
very nice. Thank you. That's nice. Huh?
Yes, sir. Thank you. Thank you very much.
Thank you.
Thank you very much.
Thank you, sir.
Thank you. I'll take leave then. Yeah.
Yes, sir. Yeah. Thank you, sir. Thank you very much.
Thank you for the session, sir.
Samir sir, thank you. Thank you very much for your postings, links. Thank you. And all the participants, thank you very much. And yeah, Samir sir, thank you. Participants, kindly register, mark your attendance in the form. We have posted in the chat box. Use that form to enter your attendance. It will help us to give certificate, issue certificate. And yeah, we will start our next session at 4:45. 5 o'clock, Samir sir will be ready, and you will have another wonderful session about new astronomical telescopes, new eyes. Yeah. Once again, thank you very much. Yeah, keep in touch. We have given few links in your mail as well as in the registration forms. You can use the Telegram link to contact us if you have any questions, doubts. Also, you can get live updates about our activities and space newses, quizzes, etc. You can learn space science with us. Thank you. Thank you very much. Bye.